The distance formula starts with 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. The distance formula comes from the Pythagorean theorem. You're finding the hypotenuse of a right triangle, so it's the square root, and the length of one leg is x2 minus x1 squared, plus the length of the other leg is y2 minus y1 squared. Okay, that's the formula. That's what you're going to plug into every time. So let's say I have the points -1, -2, and 4, -2. So I'm going to label those x1, y1, x2, y2. Here's how I learned to start the distance formula a bazillion years ago. I always do big long radical. Then I do parentheses minus parentheses squared plus parentheses minus parentheses squared. I always started with that. It just makes it easier. You don't get as confused. So now I'm going to plug in x2 is 4 minus a -1 becomes +1. y2 is -2 minus a -2 becomes +2. Now it just becomes a matter of simplifying. So this is 5 squared plus -2 plus 2 is 0 squared. That's gone, so I get the square root of 25, which is 5. The length of that line segment, the distance between these 2 points, is 5. Now let's say I have the points -3, 2, and 2, -1. So I label them. I do my skeleton, my outline, and I plug in. So I have 2 minus a -3 becomes +3. -1 minus 2 stays like that. So now I start simplifying. That's going to be 5 squared plus a -3 squared. So that's the square root of 25 plus 9. And that's the square root of 34. That does not simplify. It does not have a perfect square that divides it. It is not a perfect square, so that's my answer. Let's look at one more. Let me label my points. Draw my outline. Parentheses minus parentheses squared plus parentheses minus parentheses squared. So I have 5 minus 2, and y2 minus y1 is 6 minus 3. So that's 3 squared plus 3 squared. So that's the square root of 9 plus 9, which is the square root of 18. Now this does simplify. 9 divides that. That's the square root of 9 times 2, and I get 3 root 2. So if your square root simplifies, simplify it.